All right, guys. So it's Stephanie, and I am now finishing up the. Sorry, let me take some water. Okay, let me start this over. I am now finishing up the session that I had started on Wednesday on 1.4. We ran out of time to go through the whole section. A lot of information in that section. So I'm going to finish it up today. I've still got about 6 slides left, and I think I might have forgotten to save all of my annotations from the first document, so the upload today is not going to include the first half. So if you're going to want those notes, you're going to have to watch the video and copy them down, because I think I forgot to hit save on that when I closed the PowerPoint. So anyway, you've been hearing a black screen because I forgot to share my screen. Let me share my screen so you're not just looking at blackness. That would certainly help. Okay, so we had finished off with domain of a function, and what I had remaining was range of a function and difference quotient. So range of a function, the range is the set of all values, the output values that are taken on by the dependent variable. It's basically when you plug in numbers, what are all the possible outputs you can get if you look at all of the possibilities. So the range is the y values, and this is also when we say function values. So if you hear something that says look for function values, those are the y values, the output values. Okay, now the difference quotient. So this is the formula for a difference quotient. It is very similar to slope, and in fact it kind of is the slope formula. So the slope formula is y2 minus y1 over x2 minus x1. So let's say you were given two ordered pairs, x and 0, and then x plus h and h as your two ordered pairs. Now, this difference quotient is using function values. So instead of, your ordered pairs being x comma 0 would be f of x, and then you would have x plus h. Instead of h, you'd have like f of x plus h is your function value. So they don't have to be at 0 and h. That's just what I initially set. But if it could be anywhere, if h is anything, if we want to just write this in terms of function values, you can write it as I have here as the second set. So if you wrote your two ordered pairs that way, and you just think of f of x as being like a y value, f of x plus h is a y value, then you can plug these into the slope formula. So your y2 would be f of x plus h, minus your y1, which we have labeled as f of x. And then in the denominator, you'd have your x2, x plus h, minus your x1, which is x. And then when you simplify that, you see that in the denominator, the x's cancel, and that's where the difference quotient comes from. So the difference quotient, if you want to think about it, is the slope between any point, any 2 points on a curve. It doesn't have to be a line. It's just finding the slope between any 2 points that you're given on a curve. So it is the slope between any 2 points on a curve. I believe they call this the secant line. Because if I drew a picture, and let's say I have a cubic here, and I wanted to find the slope between here and here, I'm going to just dash it. That line formed, where that would be the slope of that line if you connected the 2 points, that's called the secant line. And so when you're using the difference quotient, you're basically finding slope out of any 2 points, and if you had a hypothetical line in between those, you're finding the slope of what that line would be. This concept is used a lot in calculus. When you get to calculus, there's something called a derivative, and the derivative is defined as the limit of the difference quotient, essentially. We're going to learn about limits in week 8, and so you'll see limits in week 8, and then once you get to calculus, you'll put that together with this difference quotient, and that will give you calculus, basically the whole basis between calculus, or behind calculus. Although in calculus, they do it specifically when you take the limit, you're now looking at tiny distances, and so the points are really, really close together, and that becomes a tangent line instead of a secant line. Okay, so I have several examples here, and these involve a lot of algebra. So these take a while because there's a lot of algebra involved. It's not hard algebra, it's just tedious. So we're just going to take this slow, going step by step. So I want to find the difference quotient, and they're giving us the difference quotient already set up, and then they're telling us what the function is. So f of x is equal to 5x minus x squared. So on the top, I have f of 5 plus h. So I need to find out what that is. So that means everywhere I'm replacing x, I'm replacing it with 5 plus h. So I'm going to just highlight so you can see that everywhere there's x, it's now 5 plus h. And because 5 is in there, if I were to, let's just, oops, that's my highlighter. Let me get my pen, get back to black. So basically, we are looking at if one of our x values is at 5, and then some distance h. So we don't know where that other point is, but one of them is definitely at 5 for your x value. So I have my expression. Now I need to simplify this as much as possible because that will make it easier. So first, I'm going to distribute the 5 times the 5 plus h. So that's 25 plus 5h. And now I'm going to square 5 plus h. So that is the square of a binomial. We have a shortcut for that. Otherwise, you can go through the FOIL process, and you will get 25 plus 10h plus h squared. So I will leave you to verify that on your own, that that's where that multiplies to. Now I'm going to distribute my negative sign. So I have 25 plus 5h minus 25 minus 10h minus h squared. And then I'm going to combine like terms. So I have a 25 and a minus 25, so those cancel out. And then 5h minus 10h, so that is minus 5h, and then minus h squared. Now, in our difference quotient, we also have f of 5. So I need to figure out what f of 5 is. So that's 5 times 5 minus 5 squared. So that's going to be 5 times 5 is 25. 5 squared is 25. So we get 0. So going to the highlighter, this f of 5 plus h, I'm going to replace with negative 5h minus h squared. And then f of 5 is going to be replaced with 0. So I'm going to be doing this on another slide because clearly there's not enough space here. So I'm going to start by writing my difference quotient. So it's f of 5 plus h minus f of 5 all over h. And they specify that h is not equal to 0 because we can't divide by 0. So now f of 5 plus h is negative 5h minus h squared. It's negative 5h minus h squared. And then f of 5 was 0. So now when I simplify, I have negative 5h minus h squared over h. And now we want to simplify, so I will factor a negative h out of the numerator. And that will leave me with 5 plus h over h. And then what happens is that our h's cancel. This h, that h, they cancel. And so we get negative 5 plus h as the difference quotient. So it's just a matter of simplification. The hardest part is this first step where you have to plug in the function values, and then that's where you're doing algebra, because you're generally squaring and then combining like terms and simplifying that before you plug it back into the difference quotient. So now I've got a second example here. So if f of x equals 4x squared minus 2x, and this time we're not given a specific number, so this is at any point x, we have our full difference quotient, x plus h minus f of x over h. So the alternate, so the first one that I did here, let me go back to that. Oops, too far. I did f of 5 plus h separately, and then f of 5, and then I plugged them in. The alternate way to show your work is to try to do everything all at once. So if we work down from our difference quotient here, we can do it all without doing separate steps. So first, f of x plus h means I need to replace my function, which with everywhere I see x, with x plus h. So that is f of x plus h right there. And I can put that just in brackets so you can see that's f of x plus h. Oops, except that I forgot my x plus h here. There we go. And then we want to subtract f of x. So I can put this in brackets again just so you can see the two pieces there. And then it's all over h. So if this f of x plus h, that gives me this portion. And then the f of x gives me this portion. Then from here, you'd be simplifying, and instead of simplifying them separately like I did in the first example, we'd be simplifying everything within the fraction. So to simplify the 4, and then in parentheses x plus h squared, I have to square that first before I multiply by 4. And then I'm also going to distribute my negative 2 through the x plus h. So I'm going to do this on the next slide. So I have my 4, and then you're squaring x plus h. So that's another square of a binomial that will give us x squared plus 2xh plus h squared. Then I was distributing a negative 2 through the x plus h. So that gives me negative 2x, negative 2h. So that is just simplifying what's in yellow. Then I need to distribute the negative sign through what's in green. So that's going to be a minus 4x squared and a plus 2x. So minus 4x squared plus 2x. And then this whole thing is over h. So now we need to simplify. And luckily, what's nice here is the minus 2x and the plus 2x, those cancel. So that's nice. I can cancel those out right away. But now I need to distribute by 4 through the parentheses. So I get 4x squared plus 8xh plus 4h squared. Now what didn't cancel is minus 2h minus 4x squared, and then this is all over h. Now I need to simplify further. So here my 4x squared and my minus 4x squared, those cancel. Thank goodness. So this leaves me 8xh plus 4h squared minus 2h over h. To simplify further, I can factor out, let's see, I can factor out a 2h in the numerator. So that gives me 4x plus 2h minus 1 all over h. So I can cross out, I can cancel out those h's. And that will give me 2 times 4x plus 2h minus 1. Or if you want, you could just not factor out that 2 at all and leave it as 8x plus 4h minus 2. It's up to you. Either one of those answers is correct for the difference quotient. Most people will end up multiplying that back out since the 2 didn't cancel and leave it as 8x plus 4h minus 2. And so that is the value of the difference quotient. And you will learn what that means once you go to calculus. So this actually has a meaning. And once we get to calculus, we start thinking about h being 0, and you plug in numbers for x, and it gives you all these things. So when you get on to calculus, which is going to be at least 8 weeks from now, that is going to be where you're going to learn more about this. So that was what I had remaining. That took about 15 minutes, and we're already 10 over with the first session. So that definitely would have been would have taken about an hour and a half what I had planned for 1.4. So if you guys have questions, you can email me, you can contact me through Hangouts or Remind. I can stop sharing. You can actually see my face this time. You can give me a phone call. There's lots of ways to contact me. So if you guys have questions, let me know. And I will see you guys again, either on another live or on another video. Bye.